Hello everyone, mic test. Hello everyone, mic test. Okay, looks like it's okay. Hello to Sing Beng Leong, Tran Nok Trung, Janavi, Leslie, Emily, Jessica, Rasmus, Kendrick, Rekha, Mark Muaz, Sagi, Jais, Rose, Samuel, Kok Yong, Annie, Ang Wei, Wendy Chia, Angeline Lo, Anusha, Jermaine, Giselle, Gareth, Aislinn, Gwendolyn, Patient, Lynn and Desmond. Hello to all of you. Thank you for being here. Okay, welcome to another Facebook Live session happening every Wednesday at 8 p.m. Sorry, let me silence my phone for a while. So a little bit about myself. I'm the curriculum specialist here at Heuristics, and I've been working here since 2011. So my job requires me to keep updated about the latest developments in primary mathematics and ways of teaching students. Okay. So this spatial visualization difference in area is part of the Mastering Heuristics series written by my mentor, Mr. Sani Tan, and this is the book that we have come up with here at Maths Heuristics. Let me just show you the ebook version so that it's clearer. And you can see that it's been written and published in Singapore since 2014. And there's a lot of content in this book. There's specifically 6 unique techniques that we are covering in this book. So today, what we'll be covering is on the difference in area. Last week, we have already covered the technique on the rearrangement of parts for circles and non-circles. So we are covering 2 of the many techniques that are in this book. So one thing I'm very proud of in this book is that I went through writing this book with my boss, vetted through some of the questions and solutions, and also created the web videos and the app for it. So let me just show you how this app works. I think we are probably the first company in Singapore to be able to have done this. Let me just show you how it works. Okay, you can see that there's a question over here, very similar to example 4 that I'll be going through in a while. The way it works is that you can look at it for the one-shot solution, or if necessary, there is a step-by-step interactive explanation for it. So the way it works is that you have to tap on the interactive panels first before they show you the next step and explain the ideas behind that next step. Okay, so this in a way is a very interactive format for students who are more tactile and kinesthetic learners. Okay, so without further ado, let me just go through the main idea on the difference in area for spatial visualization questions. Okay, example 1. The figure below shows a square and a triangle overlapping each other partially. The area of the square and the triangle is 90 cm squared and 65 cm squared respectively. Find the difference in area between the two shaded areas. Okay, now take note of one thing over here. This part is very important. Hang on, something wrong with my stylus. Okay, it's working again. Now, one thing to note is that the objective here that you are required to find is the difference between the two shaded areas. Indirectly, they are saying that the total area of the square and the total area of this triangle is not relevant. We only want the difference between the two shaded areas. And to take that even further, one step further, if we say that about the difference between the two shaded areas, we do not need to know the individual value of the shaded areas either. Okay? So since we are given the total area over here, we can make use of it. So if we want to find the difference in the area, what would you do? No, Rudula, it's not 105. Okay, so let's separate this out a bit first. The reason why my presentation slides and the notes printout alignment is different is so that I can keep everything on the screen. Okay, so let's call this portion A, let's call this portion B, and let's call this portion C. Now, if we are to draw a model to represent the area of the square, it will look like this. There is a shaded component and there is an unshaded component. Okay? And this we know is 90 cm squared. Then the next thing that we would want to do is to draw out the area of the triangle. Now, please do not draw out what I'm going to draw first. What I'm going to draw now is a common mistake that a lot of students make. Okay? So, because students are very used to drawing the model from the left side, is this the left side? They are very used to drawing models from the left side, and this is what they would tend to do. They would tend to draw a B here and a C here and say that this is 65 cm squared, and then they find that they can't really deduce any information. Okay, so to work around this, it doesn't necessarily have to start from the left side, because in drawing the models we are comparing in drawing the models, hang on, we are comparing the differences in the length. So we can also start the model from here if we wish to do so, and over here we would put B and C. Now the main idea here in model drawing is to put the repeated items on top of one another. And the reason for this is so that it can be cancelled out entirely. Now, okay, please take down the notes in red. Sorry for that. So the area of the triangle is 65 cm squared. Then over here, when we want to find the difference between the two shaded areas, the two shaded areas over here would be A and C. And let's look at what we have over here. We have A and C over here, and the difference between them, if we are to isolate this portion. This is the difference in that area. True? To get the area then, to get the difference in the area then, we have to take the entire total area of the square and subtract the area of the triangle from it. And doing so gives us 90 minus 65, which gives us 25. And hence your answer would simply be 25 cm squared. Okay? Yep, very good. No, you can't add both. If you add both, you will get the total area of the square and the total area of the triangle. Okay? Okay, very good. A lot of you got it. A lot of you got it already. Brandon, Rekha, Rudula, Ang Wei, and Jessica, Angeline too. Yeah, it looks quite complex, but the whole idea is that it's only one step. Because it looks kind of tricky if this is a bit unfamiliar to you, but the whole idea is to focus on the objective, which is the difference between the two shaded areas. Try not to get distracted by wanting to find the individual value of the shaded area. Okay, because in this question it is impossible. There is not enough information for you to find the shaded areas individually. Okay, so if you got it, please spam the like button. How much marks this one is worth? Usually 3 or 4. Probably more towards 3 because it's holding one step. Okay, very good everyone. So can I proceed to the next question? I see a lot of likes. Guess all of you are following. Okay, very good. Let's move on to the next one, number 2. So now we are still dealing with triangles and the difference in the shaded area. Okay, so this diagram here is not drawn to scale because I know that this part looks like it looks kind of like a rectangle, but it's actually a square. So ABCD is a square of side 10 cm. CEF, okay, hang on, let me just draw out the shapes as I go along. Now this ABCD is a square. CEF is a triangle. Now the length of DF is 1/4 the length of FC. Find the difference in the two shaded areas. Now if this entire length is 10 cm and this portion here is 1 part and this portion here is also 4 parts, then let's simplify out the problem first. We say that DF's length must be 2 cm, while FC's length would have to be 8 cm. Okay, maybe let me try to redraw it because I can't really see it either. Okay, DF's length is 2 cm and FC's length must be 8 cm. Simplify it first. Now having done this, now that we have understood the trick from guided example 1, and we want to find the difference in the two shaded areas, we now know that it is not so important to find the individual individual shaded areas. Agree? So now let us compare the difference in the areas between both of them. Again, I will use models to try to represent the situation. Here we have the shaded region of the square x and the unshaded region of the square y. This entire area will simply be 10 times 10, which gives me 100 cm squared. This will be the area of the square. Now over here, we want to find the area of this triangle. Okay, so based on what I discussed earlier, just to repeat the idea, do not draw this out yet. Okay, do not draw this out in blue. Okay, the common mistake that I've seen a lot of students do is that they put y and z over here because we are too used to drawing models starting from the left side. It doesn't have to be that way. Ultimately, if we are comparing differences, we are comparing the differences in length. Hence, what we can do instead, this part you all can start to draw out. What we can do instead is to put the repeated item on top of one another so that they can eliminate each other. And then we would have this z component here. And now we want to find out what this z plus y is. So let's look at this triangle again. Here we know that its base is 8 cm. Okay? So be very careful when they tell you that, when they tell you the shapes of the objects. With those shapes, those specific shapes, they come with several properties. One of them is that this length here will be 10 cm as well. And this will be perpendicular. So if I were to extend out the base of 8 cm and draw a perpendicular length to this highest point over here, this will also be 10 cm. And when we've got that, we can now find the combined area of y and z. This would be half times 8 times 10, half times base times height, and this will give you 40 cm squared. Okay, so coming back to the objective, we want to find out the difference between x and z. We will use 100 and subtract 40 cm from it. And this will give us 60 cm squared. So the answer here will be 60 cm squared. Alright. Yes, a lot of you got it too. Very interesting. Jessica, Lin, Sing Ming Leong, Rudula, Ang Wei, Vasanti, Shamshia, Jais Rose, Rekha, Brendan, Amanda, wow, so many. Gayatri, Janet Chia, no. Oh, that's very interesting. Yo Yo Zuzai. Hey, Mr. Chia. Hi, Tongan. Okay, if you got it, please spam the like button. So after this, I'll be moving on to circles. For those of you who are in P5, don't be too intimidated by the formula. To find the actual value itself, don't be too intimidated by it. stay a while and listen for the ideas. Okay? Okay, let's move on to number 3. Now, this is where it gets a bit more complicated, but the main idea still remains. When we want to find the difference in area between shaded parts, we do not necessarily need to know the individual areas of the shaded part. That is the most important takeaway for today. Focus on the objective. Okay? So now, the figure below shows a quadrant. This is the quadrant. Okay, let me use a thicker. This is the quadrant. Semicircle. And a rectangle. So the rectangle over here, okay, will be here. So to find the difference in the area of the shaded parts, I have to find somewhere where I can compare and get rid of a common area. So if we look logically at this, we can partition it into 3 separate areas. The green ones that I'll focus on, this one will be A, this portion I will call it B, and this portion here I will call it C. Okay? Yeah. Okay, so first things first, let me just get rid of this semicircle. Okay, let me just find the area of this quadrant first and get rid of this semicircle here. So since this radius of the quadrant is 4 cm and this semicircle over here must also have this entire diameter to be 4 cm, which means that each of these would have to be 2 cm. So once we have this ready, we can now find out the area of the quadrant. The area of the quadrant will be 1/4 of a circle times pi, which is 3.14, times radius, which is 4, times the radius. This will give us 12.56. Is it? Okay, so the whole quadrant will have an area of 12.56 cm squared. Then the semicircle itself will have an area of half of a circle times pi, 3.14, times the radius 2 times radius 2. So this gives you 6.28. So now if I were to take the quadrant and subtract this semicircle, this will give me 6.28, which is the combined area of A and B, this part here. Okay. So now what about finding out B and C? So for B and C, we have to focus on this rectangle here. Okay, and get rid of this quarter circle inside the rectangle. So that will be length of the rectangle times breadth of the rectangle minus half minus 1/4 times 3.14 times radius 2 times radius 2. And doing this will give us 4.86. So having done this already, we can now say that this is the combined area of regions B and C. Okay, so the difference in area between A and C, we can represent it again like this. Now between A and C, remember, try not to be fixated to the idea that your model must start from the left. We can also put the model over here and we compare this difference. This would simply be 6.28 minus 4.86. Then over here, this difference will simply be 6.28 minus 4.86, and that will give you 1.42. So the answer here will be 1.42 cm squared. Okay, very good. Now remember the key idea for those of you who just joined in. The key idea here is to focus on this difference. Everything else is not so not as important as the objective. Always focus on the objective. That is how I do things as well in real life. Okay? Okay, very good. Okay, why is it lagging? Oh. Hang on, let me just shift this working a bit. So the answer here will be 1.42 cm squared. Alright. Oh, sorry, made a mistake. So this is A and B, this is B and C. After this question, the next question will also be on circles. No, it's not B only. It's not B only. Over here, there is not enough information for you to find out the individual area of B, A, or C. No, we won't be using algebra for this. Why is it 4 cm? It's given in the diagram over here. Okay, so I can see all the like buttons already. I guess all of you are following well. Okay, that's pretty good. So let's move on. Let me silence this. Okay, number 4. If you know how to use algebra, if you know how to use it, then by all means go ahead and use it. Okay? Now, in the figure below, ABCD is a square of side 20 cm with a semicircle and 2 quadrants drawn within it. So this ABCD is a square. Of side 20 cm. You got a semicircle here. And 2 quadrants. So these are your 2 quadrants over here. Okay, find the difference in area of the shaded regions E and F. Okay. Last page, no question. Do you have the example for? Okay, so anyway, once we have this, first things first, let us just focus on this entire side. Okay, do not shade it first. We only want to focus on this entire side. And because this quadrant's area is the same as this quadrant's area, we can call these two portions, x and y. And x is equal to y because they are the same. So these two areas must also be the same inside this square over here. Now, so first things first, we find the area of the square and we remove off this semicircle. The area of the square will be 20 times 20. Then we get rid of the semicircle first. And this would be something. Okay, okay, let's just find out the area of the semicircle first. The area of the semicircle will be half times pi 3.14. Because this is the diameter of the circle. 20 cm is your diameter of your circle. Its radius has to be 10 cm. So this will be half times 3.14 times 10 times 10. This will give us 157. Okay, so now I can find the area of E and X first by taking the area of this entire green quadrant and subtracting off this semicircle here. Oh, you are quite fast. Okay, the area of the quadrant will be 1/4 times pi 3.14, and now you have to take note that this quadrant's area radius is 20 cm. So we multiply this by 20 and 20. So this will give us 314 cm squared. So the area of this E and X alone must be 314 minus 157 to give us 157. True? Then now we want to find the area of this F and X. Because you can't find the area of E or the area of Y of F alone. With primary school methods, you can't find the individual areas. So to find out F and X, we have to take the area of the square, which is 20 times 20, to give us 400, and then we subtract the area of this quadrant here. Then that will be 400 minus 314. and this will give you 86, which is the area of F and X. So once we have this already, we can now find out the difference between E and F by using a model to represent the situation. We have E and X over here, which gives us the total area of 457. We have F and X over here, which gives us an area of 86 cm squared. So if you came in a bit later, and I haven't heard me say this, you only want to focus on the difference between E and F. Okay? This would be the difference. So over here, X and X is common. It cancels out each other. And this produces the difference when we take 157 and minus 86. And this will give you 71. So the answer here will be 71 cm squared. Okay, unicorn, the reason for subtracting this 314. Okay, the entire square is 400 cm squared. This quadrant, this green quadrant over here, has an area of 314 cm squared as we've calculated over here. Okay, so a lot of you got it. Okay. Okay, you're welcome out with us. Yeah, please do not bring bring in the memes. Please do not bring in the memes over here. Okay, very good. A lot of you got it. Very good. Okay. So we've covered these two on Facebook Live this year. And of course there are of course more techniques that we haven't covered, and I don't think we would have time to do that in the public space as well. But here's the good thing. We are holding a spatial visualization parents webinar that will cover all these techniques in detail. It will be a 3-hour webinar on Saturday or Sunday. It will be covered on both days. You can just choose to attend one of them. The second day one will be a repeat of the first day's. It will be the same thing that we'll be covering. Okay, so you can view more on this link over here. Okay, let me just type in the link real quick and tell you what you will get. Yeah, Mrudula, you can do that, but you have to understand the distributive laws with negative. Okay, you're welcome everyone. Okay. So let me just briefly say and describe what you will get. The first of all is a 3-hour, this is a 3-hour webinar. Covering all the techniques in spatial visualization for area and parameter. Secondly, you will have access to the replay. And most importantly, of course, you need the notes for the webinar. It will be a printable version. And on top of that, you are going to get this ebook over here. This spatial visualization ebook that describes in detail, step by step, how to break down the questions, and the solutions will be available on another website. Okay? And on top of this is still not done. We are still not done with adding value to our clients and customers. We still have the web videos. And more importantly, at the beginning of this presentation, the access to mobile apps. Okay? What do you think the value of all this would be? All this is only for $25. 25 Singapore dollars. Okay? Hi, Mr. Chia. It's been a while. Okay? So this is our proposition. Okay, then for those of you who are still around, if you want additional questions to practice, you can come on to our Facebook group. Hang on, let me just try to move this around. Okay, for additional questions, you can come on to our Facebook group at www.facebook.com/mathsheuristics, /groups/mathsheuristics. Then search for spatial visualization. So there will be practice, there will be questions that are tagged, and there will be solutions to go along with them. Okay? More importantly, you want to use the popular search topics tags so that you can access them. Okay? Okay, you're welcome everyone. Bye bye. What is the name of the app? The name of this mobile app is called Maths Heuristics. It is available on both Play Store and iOS App Store, Google Play Store and iOS App Store. Okay? You're welcome. So if you all have any questions, I can take them now. Okay, you're welcome, Stephanie. Welcome, Sagi. Welcome, Iris. See you, Amanda. Okay, any questions? Okay, surely what if I join and paid for the webinar and am not able to attend on both days? The replay link will be sent to you nonetheless, so you can watch the replay at your own convenience. Okay? Okay, Irene, after sign up, if I miss the session, how to get my question? Ask. You can come to our Facebook group and ask it. How to join the webinar? Okay, Annie Lim is asking how to join the webinar. The webinar link is below over here. I've pinned the comment, and I think you should be able to see it. If need be, I can send you a private message on that. Yeah, Unicorn, you're very quiet because your partner in crime is not here today. Okay. Okay, Annie, I'll PM you. Yeah. Okay, I've sent it already. Unicorn, I'm not gonna answer that question. Only things that are relevant to what I'm sharing. Okay, you're welcome, Irene. Okay, so I guess if there's no further questions, this is Kevin from Heuristics signing off. Hope to see you all soon. Good night.